Okay, so one thing that we're going to introduce now is a new notation that's we're going to use when it comes with permutations, and this is going to be dealing with a new function, if you will, but we're going to denote the row vector with all zeros except for one entry, or one with a single one in the jth entry, okay, with this iota sub j, so that for example the 4 wide, we would say iota sub 2 means that there's a 1 in the second position, so j, right? J is the position. So iota 2 represents this row vector, okay? So again, iota sub j represents these row vectors where all the entries are 0 except for one entry, which is a 1, okay? So iota 1, the 1 would be in the first position. Iota 2, second position. Iota sub 4, fourth position, okay? Now, our notation for permutation matrices is going to be this. With any permutation phi, where we have phi of 1 all the way to phi of n, right? So here's our permutation. We associate the matrix whose rows are given by iota sub phi sub 1 all the way to iota sub phi of n. Okay? Now, so for instance, let's say we have this associated with the 4 permutation here. So let's say phi is given by this permutation 3, 2, 1, 4. Okay? So this is the permutation we're using. This is associated associated with this permutation is the matrix whose rows are corresponding to the iotas. Meaning, if I have this permutation matrix with respect to a permutation, I would have this, right? Because I have what? This is the permutation, 3, 2, 1, 4. So that means I'm going to have iota 3, iota 2, iota 1, and iota 4. So that means in the first row, it's going to be in the third position, 1. In the second row, it's going to be in the second position, and so on and so forth. And I get this permutation matrix. Okay? So mainly this is all about notation and understanding how that notation and how permutations are going to be used. Okay? So first we introduced permutations, the idea of the permutations, how they work. Now we're introducing this new iota notation to build our permutation matrices.